Hey, this is Rodham, and we're going to be taking a look at this question, Roman to integer here on easy difficulty on LeetCode. And for this question, we're going to get Roman numerals as one of the inputs in the function, so S string here, and we just have to convert it to the proper integer. So the question does a good job of giving us the symbol and the value. And unfortunately, it's not as easy as, oh, you just plug in this symbol for this value and just do the equation. So this would work if, for example, we had 3 i's, and that would equate to the value 3 because we can replace 1, 1, 1. But as I typed earlier here, if we have the value of 4, for example, this wouldn't work in terms of whatever math that we used before, because 1 is 1, v is 5, right? And if we add it, it should be 6, but it comes to 4 because this is how the Roman numerals operate. So how do we go on about this? A good trick for this question specifically and for Roman numerals is that if you look at the value after the number that you're on, and if that value is bigger, then you actually have to subtract the bigger number from the smaller number. So we can see that right here, just to show what I mean. So for the value 4, this is the value 1, this is the value 5, and so we just have to go 5 minus 1, and then we get the value of 4. So now that we know that, we just have to kind of iterate through the string in a way where we can just do just that. So first, we gotta have the computer understand the key value pair of the symbol to the value. I cheated a little bit and I just typed in the Roman dictionary like this, but you can do this pretty easily, right? They literally give you the symbol, you just have to kind of type it into your own dictionary / hash table. So now comes the slightly harder part where we have to kind of iterate through and count the total of the string value here. So we're going to set the total to 0. And we're going to iterate through for index in range of the length of s, right? Just a regular iteration here. And we can just set character to the Roman dict of s of I. So we don't have to type this again. So we just have to first check if the number that we're on, if the number after it is bigger than the one that we're on right now. If that is the case, we actually have to subtract from the total. So, because we're going to add the value later on, right? So let's put this into action just so we can see. So if car is greater or just trying to get my math right, yeah, greater or equal to, and we're going to paste this in here, +1, so it's going to give us the next value. If this is the case, then we're going to have total plus equal 1, right? Because the value that we're on is greater or equal to than the next one, right? So in as a visual example, we're probably looking at 6 here, right? So if we're on the value 5, the value next is less, right? So the value we're on is greater than the value next of it. We also have to check if this is just the last value here. So we can just add that in here. If len of s minus 1 equals I, or, right? So just because we can't compute the last value this way, right? Or else we'll get an error, we're going to be out of the index. Yeah, so, and else, we talked about, right, if the case is something else, like 4, right? So if we're on the I here, we gotta subtract the 1, and because the next time when we're on the 5, we're gonna add the 5, so it's gonna come up to 4 anyway when we do this iteratively. So total minus equals 1, and that should just be it. So we just return the total, and hopefully this runs all okay. Name I, and I wrote it as index, but it's the same. So let's run through it this time. have I done? Oh, you know, I don't know why I added 1. So we're just having multiple tries here. There you go. So don't make simple mistakes like that, and we should be good. And just for the time complexity's sake, we just have O of n, just because we're iterating through the length of the string, and we're gonna have constant space here. Just because we do use a hash table, but the hash table is not gonna change no matter what. Like, you could have the longest string in existence and the hash table is still going to be the same. So what we're going to be taking up space for is the hash table that's constant and the total that's going to be constant, right? So we have the O of n time and O of 1 space, and this should be it. Okay, perfect. Hopefully this helped. Thank you.